Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of our unit, Motion in a Straight Line. If you remember that in the previous classes, we have been discussing about the differentiation. These are the differentiation basic formula. I know that d by dx of x to the power n would be an n into x to the power n minus 1. Differentiation of any constant is 0. Differentiation of d by dx of x, it is a 1. Then we have already discussed about the differentiation logarithmic and exponential functions. It's then d by dx of e to the power x would be equals to d by dx would be equals to e to the power x. D by dx of ln x, it's an 1 by x. D by dx of a to the power x, which will equal to the a to the power x multiplied by log x. We have already discussed about the trigonometric functions. We have already discussed about the multiplication and division rule. This all I repeatedly revise because this is very necessary for us to keep this continue. We require a differentiation and integration in the class 11 as well as in class 12. Now the basic question is that why do we teach all this, or why you have to study differentiation in physics? Because if it would be in maths, you would be absolutely okay with this, that yes, sir, this is our part of a curriculum. But why in this physics? If you remember in the previous classes, we were discussing about the average velocity and instantaneous velocity. When I consider or when I calculate the average velocity, I calculate total distance or the total journey I have traveled divided by total time taken. And while talking about the instantaneous, we are talking about the velocity or speed at that particular time only. And to find out the instantaneous, we have been switch our focus to the differentiation. Now let's back to the track, that how differentiation can be helpful. How differentiation can be helpful according to the physics. You know this, that speed is equals to distance divided by time. Yes, can you write like this? V is equals to delta x divided by delta t. Can you? Can you write like this? Are you sure? Yes. At that time, if delta t is very close to 0, can I write like this? V should be is equals to dx by dt. Now, when I say dx by dt, I mean this is differentiation. This is differentiation of x with respect to time. This is differentiation of x with respect to time. Now let's look at the all the equations first, and then we will switch to the applications of this equations. So this is the formula for the velocity if this is distance, and this is the formula for the velocity if this x represents the displacement. Now what is acceleration? What is it? What is acceleration? You will say, sir, it's a change in velocity. Change in velocity divided by time. So if I write like this, it's an delta v by delta t. And even I can write like this. It is a would be equals to dv by dt. This is differentiation of velocity with respect to time. This is differentiation of velocity with respect to time. This is a is equals to dv by dt. Now look at this very carefully. Can I write like this? A is equals to dv by dx multiplied by dx by dt. Can I look at this very carefully? A would be equals to dv by dx multiplied by dx by dt. Now, what is dx by dt? Tell me, what is it? Yes, you are right. It is v. So this is v multiplied by dv by dx. This is acceleration. A would be equals to v into dv by dx. So let's summarize these things. Let's a formula list according to the physics. So first was the v would be equals to dx by dt, where v could be the velocity or speed, and and x could represent distance or displacement. One more, a should be is equals to dv by dt, where v again would be a velocity or speed, while t represents time and and a represents acceleration. One more relation of a, it would be v dv by dx. Now here x represents distance or position. The other terms you know. So you need to remember these three relations. This will help us. This will help us to find out a physical quantity with the help of differentiation. So let's begin with this. Let's look at this question. If distance traveled by a particle is x is equals to dq plus 3t square plus 4t plus 9. This is in meters. And find out velocity. Second, acceleration. This is the question. You have been given an x. You have been you have been given an x, and what you need to do is this x is given. This is t cube plus 3t square plus 4t plus 9. You need to find out the velocity and acceleration. Now, let's begin with the velocity. How could I do this? What are the possible options I am having? What are the possible options? Yes, you think it correctly. I can differentiate x with respect to time. This is d by dt of x. Differentiation of x with respect to time. So if I differentiate this, let's look at this. This is d by dt of t cube plus 3t square plus 4t plus 9. So that should be is equal to d by dt of t cube. Now you are having a mastery of this. This is 3t square plus 2 3 is 6 6t plus 4 plus 9 d by dt of 9. Any constant would be having a 0. So this is 3t square plus 6t plus 4. Are you clear with this? Are you? Yes. So half of the bottle has been won, and the other acceleration would be the required. Let's look. Now you need to find out second case. It is then acceleration. Do you remember its relation? Do you remember relation of acceleration? We are having a two relation. One of the option was the dv by dt, or another option would be a is equals to v dv by dx. Now whatever the data I am having, that is v would be is equals to 3t square plus 60 plus 4. This is the data that I am having. Now tell me that which one could be used. This relation or relation number say 1 represents the differentiation of velocity with respect to time, and this another relation represents the differentiation as v multiplied by dv by dx, which could help us if I am having a time. This could help me a first relation, but if I am having a position or if I am having a distance, then the second relation could be helpful. So what should be the better option? What comes to your mind? Yes, you are right. It's an first option. So if I differentiate this with respect to time, it is an A should be is equals to d by dt of v. This should be d by dt of 3t square plus 60 plus 4. That will give me a, this is 60 plus 6. Again, this is meter per second square. This is the acceleration. What I am having. Yes. Are you done with this? Are you done with this? Are you sure? Can I add something to this questions? It's the same question. They have also asked that find out velocity at t is equals to 2 seconds and acceleration at t is equals to, let's say, 4 seconds. Now tell me what is velocity? Our velocity where this is 3t square plus 60 plus 4. It is 3t square plus 60 plus 4. And my acceleration was, it's a 60 plus 6. Now what I require? I require that velocity at t is equals to 2 seconds. So if I replace this value in place of a 10, this is velocity at 2 seconds would be equals to 3 into 2 square plus 6 into 2 plus 4. This is 3 4s are 12 plus 6 2s are 12 plus 4. It's a 24 plus 4. This is 28 meter per second. If I do this, this is 60 plus 6. This is equals to 6 multiplied by 4 plus 6. So that should be 6 4s and this is 24 plus 6, which gives me a 30 meter per second square. Now go 2 classes back. What we were supposed to do and why we are doing all this. Because I need to find out a speed or a velocity or an acceleration at that particular instant of time. So this is the same thing, don't you think so? This is acceleration at 4 seconds. This is velocity at 2 seconds. So if someone asks me that you have traveled your journey from 4 o'clock to 4:30, what was your speed at 4 o'clock and 2 minutes? So I can definitely tell him that this should be my speed according to the or with the help of a differentiation. If it is a practical situation, if it is a practical life situation, then who will give me the value of my instantaneous speed? We have already discussed. Tell me which tool were there which can provide me an instantaneous speed. Yes, you are right. It is the speedometer available in our vehicle. That speedometer shows velocity or speed at that particular instant of time. But when we are doing this on pen and paper, only the differentiation can help us to find out to find out acceleration or velocity instantaneously. So now are you clear that why we are studying this? Because from 3 classes we have been discussing all this. So this is the location. This is why we are just doing these things. Yes. So let's do the next question. Now this is not new for us, for you. You already know what is differentiation. You already practice it a lot. So now you can do this on your pen and paper very carefully and neatly. So let's look at the question. If displacement of a particle is given as x would be equals to t square minus of 4t plus 9 meter, you have been asked that find time at which particle comes to rest, maybe momentarily, but it comes to a rest. Now go through the data carefully. What they have given is that displacement of a particle is given, and displacement of a particle, it is an x equals to t square minus 4t plus 9. You need to find out the time at which particle comes to rest momentarily. Now what happens when particle comes to rest? Yes, the data that comes in your mind is that an object or a particle is not moving. That means we are calling it that you are at rest. But can I write like something like this? When particle comes to a rest, when particle comes to a rest, its velocity would be a zero. Yes. So yes, if this happens, I am having a displacement. Can I reach to the velocity? Can I? How? Yes, using a differentiation. So V should be is equals to dx by dt, and this seems to be d by dt of t square minus 4t plus 9. So if I solve this, it would be a 2t minus of 4. But at that instant, velocity should be a 0. That has been given in data. So if 2t equals to 4 and t is equals to 2 seconds. So this just represents that during the journey of this particle, during the journey of this particle, at t is equals to 2 seconds, this particle must be at a rest. Yes. What was your answer? Was it the same? Okay, great. Let's move to the next question. If if position of a particle is given as if position of a particle is given as x should be is equals to t square minus of 60 plus 9 meter, find out distance traveled by a particle in first 5 seconds. You need to find out the distance traveled by a particle in first 5 seconds. Go through the data very carefully. Go through this. First, you should understand that this is the position, not the distance. This is position. It is the location of a particle at that particular instant of time. That has been given as x is equals to t square minus 60 plus 9. You need to find out the distance. Remember this. You need to find out the distance traveled by a particle in first 5 seconds. So how could you do this? How could you do this? while doing this kind of question, you need to check that whether my particle comes to a rest at any particular instant in which I am interested. Look, I am interested in motion of a first 5 seconds only because that is only they have been asked. So I need to check that does my particle came to a rest within this reference time, within a time of a 5 seconds. So what should I do is I have been given a position. This is t square minus 60 plus 9. I can differentiate this. And while differentiating, I am having a velocity. This is equals to 2t minus 6. I need to check that if particle is at rest, if particle is at rest anytime, then v should be 0 and v is the 2t minus 6. So that should be equals to 0 equals to 2t minus 6 and t is equals to 3 seconds that you know. Yes. So your particle comes to a rest at t is equals to 3 seconds. And this 3 seconds came in between to our journey of first 5 seconds. So now what should I think is that my position will look like this. It's a t square minus of 60 plus 9. X is equals to t square minus 60 plus 9. And my particle comes to rest at t is equals to 3 seconds. Now, did you remember the question? What you need to find out? Yes, you need to find out distance. So let's find it out. Positions at different time. Let's find it out the position of a particle. Let's find it out at the 0 second. Do not ever assume that your particle would be at 0, 0, 0. No, this is not possible. Let's put t is equals to 0. T is equals to 0 in the x. So this is 0 minus 0 plus 9. Look, your particle is at 9 meter at at t is equals to 0 second. Now, on the second stage, find out the position of a particle at the second when it has been raised at t equals to 3 seconds. So t is equals to 3 seconds. It would be 3 square. It's a 9. Minus 6 threes are this is 18 plus 9. So this is 9 plus 9 minus of 18. This is 0 meter. This is 0 meter. Now I need to study the motion up to 5 seconds. So let's put it 5 seconds. This is 25 minus of 6y is a 30 plus 9. This is 25 plus 9. That is 34. 34 minus 3. This is 4. Now what you need to find out? What you need to find out? You need to. You need to calculate the distance traveled. So for your reference, I would like to put this on a number line so that it would be a clearer. Let's see. And this is probably a 0. This is probably a 4. This is probably a 9. Initially, if I give a number, this will be the first, this will be the second, and this will be the second. Initially, you are here. This is location number 1. Next stage, on a next stage, you would be same at the 0 meter. So you must have traveled from this position to this position. Mind you, we are talking about the distance, so we don't bother about the directions. We are just interested in the magnitude. So from 9 meter to 0 meter, I have been traveling from 9 meter, total distance of 9 meter. Now, from 0 meter, you have been at 4 meter. So this is the third location where you have been from. This is the distance you must have traveled again 4 meter. So if I am talking about the total distance from 9 meter to 0 meter, you must have walked for the 9 meter. From 0 meter to 4 meter, you must have been walked for the 4 meter also. So total you have traveled for the 13 meter. This is the exact answer. Now one more very interesting aspect is that look at this. You were at rest at t equals to 3 seconds. You were at rest at t is equals to 3 seconds. So if you look at the situation very carefully, you have been started with this. You have been gone through this. And from this, and from this, you have taken a U-turn and you have reached to this. Yes. So what would be the situation if a particle takes a U-turn, the distance and displacement would be different with here I have been supposed to find out distance. That's why I need to add everything that I have been worked for. But if I have been asked that what would be the displacement, please remember this very carefully. If I have been asked what would be the displacement of a particle for first 5 seconds. So, what was the situation? You started with this and you ended up here. You started with this and you ended up here. So, displacement would be 5 meters. Initially 9, finally 4. The difference between this two. And my distance is 13 meter. Yes. Are you done with this? Do you understand this complete situation? Let's relook at this. Let's relook. This is very important that they have given is first thing they have asked about the position. If position of a particle is given as and the position is given, then you need to find out the distance traveled. You need to find out the distance traveled by a particle in first 5 seconds. So when this kind of question arises, first you need to check that whether my particle comes to rest within that frame of time where I am interested. Here I am interested in the first 5 seconds of the journey. So if I look at the x, it is x t square minus of 60 plus 9. I want to check that whether my particle comes to a rest within a 5 seconds or not. If it is there, then when it has been come to rest. So how can I check that whether my particle comes to rest or not? First, I need to differentiate that so that I can have a velocity and then I can compare it with the zero. If it is a valid amount of time, that means if it is a positive number and that positive number came to my reference, that is a 3 seconds and my reference is for 0 to 5 seconds. So here it is a 3 seconds. So when it comes within our journey, that means we must be sure that my particle will take a U-turn at certain instant of time, and that instant of time would be the same time where its velocity would be a zero. So one very good conclusion is when particle comes to momentarily rest, it will take a U-turn. Please remember this thing. This will very helpful to us even in the kinematic equations. So when particle comes to a rest, it will have a U-turn and it will change its direction. So what next? I have been find out that at t equals to 3 seconds, my particle comes to rest. Next, find out the position of a particle at 3 instant. Remember this very carefully. First, initial at the origin at t is equals to 0 second. At t is equals to 0 second. Next would be that situation where my particle has taken a U-turn or at that position from where my particle was at rest. Then that means a 3 seconds. And last, where my journey would be ended. It would be a 5 minute. Then you need to calculate the distance travel and just add them up. So now I hope you are comfortable with this and you must perform this kind of question. Are you sure? Okay, let's look. The data is given that if position of a particle is x is equals to t square minus of 4t plus 9, and you have been said that find out distance and displacement of a particle in first second. That means I need to see the journey of 1 second only, in first second only. So let's begin. What should I do? What should I do? They have given me the position, and it seems like this. It is a t square minus 4t plus 9. So what should I consider that? Whether my particle comes to a rest or not. If it is, let's check that at which moment it comes to a rest. So what I have given is x is equals to t square minus of 4t plus 9. If I differentiate this, v should be is equals to dx by dt. That would be is equals to 2t minus of 4. And that would be a 0 because I need to check it. So if I compare this with the 0, this comes to a 2t is equals to 4 and t is equals to 2 seconds. So yes, this particle comes to a rest at time of 2 seconds. But this 2 second is not in my hand because I need to just check the motion. I need to just check the motion at time or within a time of first second. So what I can do is I'm just interested in finding out the position. Find out positions. So let's check that what was your position at t is equals to 0 second. It is 0 minus 0 plus 9, which is a 9 meter. You were standing at 9 meter. Now, what was your position at first second? That is t is equals to 1. This is 1 minus 4 plus 9. It is a 9 plus 1, 10. 10 minus 4, it is a 6 meter. So at t is equals to 0, you are standing at 9 meter. At t is equals to 1, you are standing at 6 meter. So total distance that you might have traveled. You are beginning your journey with 9 meter. You are ending up by 6 meter. So total distance that has been traveled is 3 meter. Now one more thing that came to in your mind is this is the distance. What about the displacement? First tell me, did my particle have taken a U-turn in 4 seconds? No. Then it is sure that we have learned this in a concept of distance and displacement that distance and displacement will be equal if if your particle is not having U-turn. Here particle have does not have any U-turn within first second. So my total distance and total displacement would be equal. What was your answer? What was it? What was it? Okay. Did anyone make a mistake that they have taken a total distance as a 9 plus 6 is equals to 15? I'm sure many of you have did it. I'm sure for this. Please don't do this. This is the position. We are here to find out the position, and then according to the position data, whatever I have been receiving, I need to go through it. These are not the distance. Yes, this term a 9 meter or a 6 meter, they are not the distance. They are just the position of a particle. You need to consider that at initially you were standing at 9 meter, and finally that means that t is equals to 1 second you were standing at 6 meter. This is what they have given. This is what they have given. Did you understand these things? Are you sure? Are you sure? Okay, let's move to the next question. Let's say they have given us uh, displacement of a particle is given as x equals to a into e to the power alpha t plus b into e to the power minus of beta t, where alpha and beta is constant. First question would be find out velocity. This is what they have given. That displacement of a particle is given. Displacement of a particle is given, which is x is equals to a into e to the power alpha t, x equals to a into to the power alpha t plus b into e to the power minus of beta t. Alpha beta is constant, alpha and beta is constant, even a and b are the constant. So you need to find out the velocity. How could you do this? You need to find out the velocity. How could you do this? What I can write is v should be is equals to dx by dt. This is equals to d by dt of a into e to the power alpha t plus b into e to the power minus of beta t. So you need to differentiate first this d by dt of a into e to the power alpha t plus b into e to the power minus of beta t. This is my so what could be the answer? Let's say the situation was something like this d by dt of a into e to the power alpha t. Just rewrite this b into e to the power minus of beta t. So now solve this. This is a multiplied by e to the power alpha t. I need to differentiate this. Did you remember the chain rule? Yes, you need to multiply the e to the power alpha t as an e to the power alpha t, and you need to differentiate this one more time, which is an alpha that needs to be multiplied plus e as it is into e to the power minus of beta t, and let's differentiate this one more time, which is a minus of. So this would be the situation a into alpha into e to the power alpha t. Here this is the term as a minus of b into beta divided by e to the power beta into t. This is my velocity. This is my velocity. Now, if I want to analyze this, if I want to analyze this in a more detailed approach or in a more detailed way, tell me what happens to velocity if time increases. When I say what happens, when I say what happens, I am interested in two aspects. That whether it will increase or decrease. I'm interested in this two aspect, whether it will increase or decrease. Now, look at this question again and again and very carefully and tell me what would be the situation? What could be the situation? Look at this again and again and tell me if time increases, if time passes, what happens to the velocity? What would be the situation? Let's try to imagine the thing that if this term increases, if this term increases, then this complete term must be more positive. That if time increases, this e to the power alpha t must be a positive, and this must be an increase. Now, now, if time increases in this case as well, then this term would be increases. This term would be increases. Which in turn, this term has a complete decreases. So if you look at this, this is more positive, this is more negative. So as time increases or as time passes, velocity increases. This is a question which have been asked in both level of competitive examinations. When I say both level of competitive examination, I mean this has been asked by advanced as well as this has been asked by the AIMS examinations. Yes, now there are no aims would be taken, but AIPMT would be there, mains would be there. That means when I say AIPMT, it would be a NEET conducted by NTA, and mains and advance is always there. So this kind of questions would be asked. This kind of questions could be asked, and that can be solved. That can be solved. Now let's look at the next question very quickly. Let's say they have given that if velocity of an object is v should be is equals to v should be is equals to 2x plus 3 meter per second. Find out find out acceleration of an object at x equals to 2 meter, and go through this data carefully. What they have given is they have given the velocity of an object, and the velocity of an object is 2x plus 3 meter per second. You need to find out the acceleration at at x equals to 2 meter. You need to find out the acceleration of an object at x equals to 2 meter. How could you do this? What can be done? Now, if you remember within your mind or back of the mind, you might be having this two clues. First would be A is equals to dv by dt. First would be A is equals to dv by dt. And the second one, that came to your mind is A should be is equals to v dv by dx. A is equals to v dv by dx. So, which are the base suitable to you? What can be done? Tell me what could be done. Yes, this is the best suitable option. A is equals to v dv by dx. So let's go with this. That acceleration should be is equals to v dv by dx. This is equals to 2x plus 3 multiplied by dv by dx. So first let's calculate this. Let's calculate d by dx of v, which could be d by dx of 2x plus 3, which will give me a this is d by dx of 2x, which is a 2, plus d by dx of 3, it is a 0. So if I multiply this, that this is 2x plus 3 multiplied by dv by dx, it is a 2. So this acceleration would be equals to this is 4x plus 6. I need an acceleration at x equals to 2 meters. So this is 4 into 2 plus 6. This is 4 to the 8 plus 6. This is 14. This will be the 14 meter per second square. Yes. Did you understand all these things? Are you sure? Are you sure? Great. Let's move to the next question. If displacement of a particle is given as x is equals to a sine omega t. You need to find out acceleration of particle. Now, the data that I am having is x. This is a displacement, which is a sine omega t. And what I need to find out is I need to find out the acceleration. So what can I do? What can I do? If I draw a mind map, this is the displacement. If I differentiate it once, I am having a velocity. If I differentiate the velocity, I am having acceleration. Yes. So what I can came to the conclusion is that if I differentiate displacement twice, if I differentiate displacement twice, I must be having an acceleration. And if I differentiate displacement for one time, it is a velocity. So what I can tell is that v should be is equals to dx by dt that I know. And even I know that a should be is equals to dv by dt. So this can be written as d by dt of dx by dt. And if I write this, this should be pronounced as d square x divided by dt square. While I write this as a square, I mean to say, I mean to say that this is, I mean to say that this is second order derivative. So if I write a general term, if I write a general term, d to the power n x divided by dt to the power n, that means nth order derivative of x with respect to time. This is nth order derivative. Please remember this thing. This is nth order. So this is the second order derivative. And second order derivative, which means I need to just differentiate this quantity twice. If it would be a third order derivative, that means I need to differentiate this. I need to differentiate this three times. So let's back to the question. They have given is x is equals to a sine omega t. Differentiate it once. It's a v would be dx by dt. So a would be as it is. If I differentiate this sine would be the cos omega t. Remember the chain rule. I need to differentiate this omega t one more time. And that amount would be a multiplied. Now d by dt of omega t. What it would be? Yes, it is an omega. So this should look like a omega cos omega t. Now again one more time. This is equals to dv by dt. So this should be d by dt of a omega cos omega t. So that should be a omega would be kept as a constant. Cos of omega t. Cos of omega t will give me minus of sine omega t. Again applying the chain rule. Omega t should be differentiated one more time. That means it's a d by dt of omega t, which is an omega. So this would be minus of a into omega square into sine of omega t. Yes, have you done this? Yes. So if you have done this, E should be is equals to minus of omega square multiplied by A sine omega t. So this is equals to minus of omega square. Can I write this as an x? It's an A sine omega t. Look at this. So this is equals to A should be is equals to minus of omega square x. This would be the correct answer. Did you reach up to this? Are you sure? Yes, great one. Now, you will learn this that this is condition for simple harmonic motion. So, SHM in last second unit of 11th class. Last second unit of the 11th class. This is simple harmonic motion. So, a very long run to go, but remember these things. Yes, let's wind it up here. We have been done with the differentiation. Now you must know everything about the differentiation that can be used in physics. You can do each and every questions that can be asked in physics according to the physics. So please do practice. I have divided the differentiation in three segments so that you get a time or ample amount of time so that you can solve maximum amount of questions. So please make a practice a lot. Make a practice a lot. This will save us. Thank you. Have a good day. Take care. Bye bye.